So here is the code for lab 4. This lab, we're supposed to drive straight 100 centimeters, as straight as possible using encoders, and drive back 100 centimeters using encoders. So to start out, for the left and right speed, I chose the left speed of 70, a right speed of 78. And down here, as soon as the button is pressed, pause for 2 seconds, call the drive straight function with f passed in the parameter, wait 2 seconds, and then call the drive straight function, but this time backwards. So here in our drive straight function, the first thing we do is we reset both left and right encoder counts to 0. And if we pass f in the parameter, this represents the forward, and so we're going to call this while loop right here. So while the left or the right encoder count is not equal to the number of pulses, we're going to keep looping through here. We're going to set the left and right motor speeds to 70 and 78. We're going to get the encoder counts so we can keep track of where we are in the while loop. And in this algorithm right here, the left encoder count is going to be, the left motor is a little bit faster than the right motor. So that means the left encoder count is going to be more than the right encoder count by just a little bit. And so we have to account for that right here. And so if the left encoder count is greater than the right encoder count plus 3, then we're going to decrease the left motor speed by 1. And conversely, if the left encoder count is less than the right encoder count plus 3, then we're going to increase the left motor speed by 1. Now, if either of the left or the right encoder counts are greater than or equal to the total number of pulses that we need to travel, in this case it's 100 centimeters, then we stop. We stop either the left or the right or both motors. And we've passed in b to the parameter. We're going to execute the same function that we did up here, except if you notice we changed this to the negative values to represent the fact that they were going backwards. Right here too, negative left and negative right speeds. And these if functions are the same if statements up here, except since it's going backwards, we're going to swap these operators right here. So up there it was count left is greater than count right. In this case, we're going to swap it if count left is less than count right. And of course, we decrease the negative left speed, which actually increases it. And same thing right here. So we just swap this sign, this operator value, this comparing value right here from less than to greater than, and accounted for the negative effect and swapped. So up here it was left speed plus 1. Oh, it was left speed minus 1, my mistake. Negative left speed minus 1, yeah. And so right here, same concept. If the negative value is less than or equal to the negative number of pulses, then we're going to stop either the left or right motor, respectively. And here is the count for distance function that was already given, which calculates how far the motors need to travel given a certain distance. So up here, I'm going to press the upload button. Done uploading. There it is. All right, we're going to monitor the pulse count up here. So go to Tools, Serial Monitor. Let's clear this. Okay. I'm going to press the A button right here. Okay, pretty accurate to the total amount of encoder counts we needed to travel 100 centimeters. Now I'll go ahead and unplug it and run it on this 100 centimeter line that I marked here on the ground. So start it about right here. Okay. And as you can see, that was very accurate to where it started. So there's lab 4.